Okay, so this is a video just in case for those of us who missed today's meeting to just catch up and see how to do today's work. Okay, so we've been looking at how to use, so before we've been using the perimeter ratio to find the area ratio so that we can go ahead and find the area of a figure. Now, we're given the area ratio, right? So a squared over b squared, but we're moving towards just getting our perimeter ratio or the scalar factor. So we're going backwards. So let's look at this problem over here. We have two triangles and they're similar figures. And the areas are 20 feet squared and 4 feet squared. And we're trying to find scalar factor and the ratio of perimeters. Now, from the notes from before, when we're talking about scalar factor or ratio of perimeters, they're going to be the same thing, okay? Ratio of, I'm just going to call it Perry. Yeah, so they're going to be the same thing. So um, it's just how it's been set up. So we have these two areas, and we're going to put them as a, what's that called again? As a ratio. So you can either write 4 over 20 or 20 over 4. I'm just going to write it like this because I see them piled up like this. And this one was my area ratio. Now, in order for me to get my perimeter ratio, or just a plain A over B, I need to make sure I'm square rooting both the numerator and the denominator, okay? So the denominator, it's already a perfect square. So square root of 4 is 2. And the square root of 20, I'm going to break that up by writing down the factors of 20. So I know it's 1 times 20, 2 times 10, and 4 times 5. Now, these are my three options, but between these three options, one of them I'm going to use. And that one is going to be 4 over 4 times 5. I'm using that one because 4 is a perfect square, and it's the biggest perfect square from all the other bunches, right? 1 is a perfect square, but it's slow. It's going to be 1. 20, the factors don't match, so it's not a perfect square. So the same stories with 2 and 10. Each of their factors don't match, so none of them are perfect squares. So I'm not going to use that. So now I'm going to separate like this: square root of 4, square root of 5. And to simplify this even further, this square root of 4 is going to become a 2 square root of 5 over 2. And just remember, whenever we're finding these ratios, you want to get it to simplest form. I see a 2 over 2, crossing those out. And my ratio, my perimeter ratio and scalar factor will be the square root of 5 over 1, and that is my answer. Now, let's look at a different problem. We have two regular pentagons this time, and they gave us these areas, and oh, these areas have square roots in it. So even though it's a different shape, it's going to be the same idea. Their area ratio is going to be the same. I mean, the same setup. Okay, so we have this set up already. Now, before I can do anything, I can actually simplify this because there's a square root of 13 on the numerator and there's 1 in the denominator. So if I were to simplify it, it'll just be 81 over 1. Now, for me to find that plain perimeter or scalar factor, I need to do the opposite of squared, the square root, and I'm doing that to both sides. And 1, that's a perfect square because they have this, their factors are the same number. 81, it has the factors of 9 times 9, which are the same number, and so that makes 81 the perfect square. So 81, square root of 81 becomes 9, and the square root of 1 just becomes 1. Okay? So now 9 over 1, I can't simplify this any further, so this will be my final answer. That is my ratio and my scalar factor. And then we're done. Right? So yeah, that's what we're doing. We're working backwards and we're just trying to find the new area, the perimeter ratios.